Hello NIE students, welcome to the CAD/CAM laboratory. In this lab session, you are going to learn about how to model the parts of flanged coupling, which is a protected type, and how they can be assembled together, and how we can generate the orthographic views, that is front view, top view, and side view of the assembled flanged coupling. As it can be seen in the bill of materials table, this flanged coupling of protected type is having 6 parts. Okay, flange number 1 is the first part, flange number 2 is the second part, shaft is the third part, taper key is the fourth part, external headed bolt is the fifth part, and external nut is the sixth part. And flange number 1 and flange number 2 are used 1 in number. Okay, and 2 shafts are used, 2 taper keys are used, 4 external bolts are used, and 4 external nuts are used. And you need to remember that couplings are used to transmit the rotary motion from one shaft to the another shaft whose axis will be collinear. Okay, so therefore with help of this flanged coupling we can transmit the power from one shaft to the another shaft. Okay, so now let's have a look at the part drawing sheet of this flanged coupling of protected type. Okay, again in this bill of material you can see that there are 6 parts, and this part drawing sheet will be provided to you in the examination. Based on this part drawing sheet where different views, that is front view, top view, and side view of the coupling parts, different coupling parts are given, will be given to you. Based on this part drawing sheet, okay, you should be able to model the individual parts, and then you should go for assembling them, and you should then you should convert the 3D assembly into the 2D drawings. Okay, so therefore what we do now is we will see how the flange number 1, that is the part number 1 of this flanged coupling, can be modeled. So let's search for the part number 1. Part number 1 is given somewhere here. So they have given the front view. So this is the front view of the flange number 1. Okay, and this is its corresponding left view. Okay, so for the part number 1 they have given the front view and the left side view. So with help of these two views now we should go for constructing the, or we should go for modeling the flange number 1. Okay, we have to get the 3-dimensional representation of the flange number 1 in SolidWorks 2015 modeling package. Now I am going to click on new part. So I will select the new part to be created, then click on OK, and then go for selecting the front plane. Okay, then click on sketch. So here the sketching will be made on the front plane, because as it can be seen in the front view of this flange number 1, okay, we can see different diameters here. Okay, this is actually the hub, the portion of the flange. Okay, so this is the flange portion. Okay, so therefore since the hub diameter is 100 mm, okay, and we can see here there is an inner diameter of inner diameter here is 50 mm, and also when you, as you can see in this side view, left side view, okay, so there are circles. This clearly indicates that this flange, these flanges, that is both flange number 1 and flange number 2, are hollow cylindrical components. Okay, so therefore these parts can be modeled by using revolve feature. Okay, when we want to model the parts using revolve feature, again we go for creating the profile of the component on one side of its axis. So in this case this is the axis of the flange. Okay, so with respect to this axis of the flange we are going to create the upper profile. So from where we have to, so again you need to remember this, both flange number 1 and 2 are the hollow components. Okay, hollow cylindrical components. So therefore the profile is going to begin from somewhere here. Okay, so we have to treat this particular point as the starting point, then draw vertical line, then horizontal line, then vertical line, horizontal line, vertical line, horizontal line, vertical line, again small horizontal line, then vertical line up to here, then come back to the starting point. Okay, so this is the profile. So this profile needs to be constructed in the front plane in the SolidWorks. So therefore I have selected the front plane. I will select the line command now. Okay, and first I am going to construct the axis, since it is a hollow component. Okay, so I will create the axis first. So therefore let me create the axis towards the left side of the origin. Once I create the solid line, I will select that solid line, and I will make that as for construction purpose. Okay, so that solid line has been converted into the axis line now. Then I will select line command. Okay, so then by taking this as the reference, so from somewhere here now I am going to draw. So as I told already, so I am going to choose this particular point as the starting point. Then I will draw one vertical line first. So draw the vertical line first. Okay, then the horizontal line up to here. Okay, so horizontal line, then again vertical line corresponding to this. Okay, vertical line will be constructed. Okay, then again horizontal line here, horizontal line, then again this vertical line here, small vertical line, then again horizontal line up to here. Okay, so then vertical line from here to here. So it will come up to somewhere here. Okay, then small horizontal line, which you can see here, small horizontal line, which is corresponding to the diameter of 75 mm here. Small horizontal line has to be constructed. Okay, and then one vertical line up to somewhere here should be constructed like this, and then come back to the starting point. So this is the rough profile, rough upper profile. Okay, rough upper profile of this flange number 1 with respect to its axis. So therefore what I do now is first I am going to bring the left end of the axis. So I am going to bring this left end of the axis and one of the left end point on this created sketch, that is this one. So I am going to bring these 2 points on the same vertical line. Then I am going to select one of the right end point on the created sketch. Okay, extreme right end point, that is either this or this will be selected. Then holding the control key I will select the origin. Okay, and I am going to bring these 2 lines on the same vertical line like this. So then what I do is I am going to define now what is the overall length of this flange. So the length of the flange is actually, as you can see here, okay, so the distance from here to somewhere here is actually 80 mm plus 5 mm. So therefore what I do now is I am going to give the overall length of this one as from here to here as 85 mm. Okay, once the overall length is defined as 80 plus 5, that is 85 mm. So then what I do is I go for giving the diameters. So when I try to give, or before to that, let me even add the other horizontal distances here. So this portion should be 5 mm. So therefore this particular portion should be 5 mm now. Okay, so then what I do is I will go for adding this next smaller dimension is this one, that is 25 here. That is the distance from this line. Okay, the distance from this particular line to this line should be 25. This will be added. Okay, so then I am going to enter the distance from, okay, so this particular point to this particular point, that is the distance from this line to this line should be 46 now. So that is the distance from actually here to here should be 46. Give that. Okay, so then is there any other horizontal distance? I think no. So now we will move on to adding the diameters. Okay, so diameters can be seen in the front view as well as in the side view, left side view. So what we do is first let me consider the smallest diameter now. So the smallest diameter corresponds to the shaft diameter of the shaft hole. So you need to remember that this is the inner surface of the flange. Okay, so to this particular hole, okay, the shaft will be inserted. So therefore this particular inner circle corresponds to the diameter of the shaft hole. Okay, so that is given here, it is 50 mm. So if it is 50, then we can go for defining the distance from, okay, so this line to this line as the you need to remember this is the axis. Okay, so from the axis here, okay, from the axis, okay, so the inner surface of the shaft hole is present at a distance of 25 mm, that is half of the diameter, that is in this case it is 50 divided by 2. Okay, so it has been defined. Then I am going to identify the next highest diameter value. Next highest diameter value here in this case is this circle, this dashed circle. So let's see, okay, to this dashed circle, let's try to identify to which dimension, this dashed circle is going to match in the front view. Okay, so as you can see here, this dashed circle, okay, so is going to match with it is going to match with this one. Okay, so that is the diameter of 75 mm. So if you try to extend the horizontal line here, okay, so this dashed circle corresponds to a diameter of 75 mm, okay, in the front view, that is this distance. So therefore what I do now is I'm going to give the distance between, okay, so I'm going to give the distance between this particular line here, okay, or this point to this axis as 75 by 2. Okay, so then next highest diameter circle is this one. This particular continuous circle corresponds to, okay, this particular edge here. Okay, so this edge is having, that is up diameter actually. So this up diameter is 100 mm here. Okay, so therefore what I do now is I am going to give the distance between, okay, this particular line and here as 100 by 2. Okay, so then what we need to do is we have to give the next we have to give the diameter of the next highest diameter circle, that is this one. Okay, but this corresponds to the pitch circle diameter. Okay, pitch circle, this corresponds to the pitch circle on which 4 bolt holes are made, but it is not actually required right now. I will move on to this one now. So this circle, continuous circle, okay, or the second inner circle from the outside, okay, so this one actually having a diameter of 200 here. So therefore I am going to give the distance from this to this as 200 by 2. Okay, 200 by 2, and also I am going to give, so since this particular blue color line now is now appearing in is now let me tell like this. So since this particular line is appearing in blue color, we can go for dragging this up. Okay, means it is not completely constrained. So okay, so I can go for giving. So you need to remember this second inner circle from the outside, okay, so corresponds to this particular line in the front view, while the outer circle now in the left side view corresponds to the top edge here in the front view. So therefore the distance from here to here is actually how much? 216 mm. Okay, so that is the diameter of the outer circle is 216 mm, or the outer diameter of the flange is 216 mm. So I am going to select this, and this axis now I am going to give this as 216 by 2. Center this. Okay, so we have got the rough profile now. So once we get this rough profile of the flange, okay, so sorry, it is not rough profile, it is the exact profile now, because we have added all the dimensions. Okay, so it is the exact profile of the given flange, okay, above its axis. So therefore once it is done, we can see the sketch is fully defined here. Then you can come out of the sketch plane, then you can keep the you can change the view of this sketch to isometric, okay, and you can see where it is constructed. It is constructed in the front plane. Now select the sketch one again and go to the features command manager tab. There you select the revolve option. Okay, we have to add the material within the created profile, but we have to add the material around the axis. Okay, so select the revolved boss. So then since already the axis was created, automatically software has identified axis here, and material has been added for 360 degree. If you want to give this as 270, you can, it is going to appear like this. Okay, so this is when 270. Okay, so and if you click OK, it will look like this. Okay, so but if you want to edit this one, again right click on this revolve one and go to edit feature and change this to 360. Okay. Okay, so this is the initial model that we have got, okay, with the help of revolve feature. Okay, or the revolve command. Now what we need to do is, if you look at carefully, okay, so somewhere here there is a 2 into 45 degree chamfer on this circular edge. Okay, that is this circular edge, which is corresponding to 75 mm diameter, should be chamfered with a length of 2 mm and 45 degrees. So what I do is I will go for using which one? I will go to the features tab. There I will go to the fillet. Under the fillet there will be option of chamfer. Select chamfer. Then this select this circular edge, and then here give the chamfer length as 2 and angle as 45 degree. Then click on OK. So second feature has been added to this which one? Flange number 1. Then what I am going to do is okay, so we should go for making this keyway in the flange. You can see here in the left side view there is a keyway here. Okay, so half of the keyway should be there inside the flange. So therefore because half keyway will come in the which one? Shaft. Okay, here, and another half portion of the keyway will be inside the flange hub. Okay. Okay, so therefore what we do, we have to cut the keyway, and this keyway so is having taperness here, so we are going to use the taper key here. So that particular taper key will have or the keyway will have a slope of 1:100, means when we move from, so you need to remember, when we are going to move from this side to this side, that is right side to the left side, okay, for every 100 mm length, okay, from right to the left, 1 mm height of the 1 mm height should be decreased. That is the meaning of this taper 1:100. For every for every 100 mm length from right to the left, okay, there should be reduction of 1 mm in the height of the keyway. Okay, so that is how you need to read this taper of 1:100 now. So in order to create this keyway, so what I do is I will select the front plane in the SolidWorks, and I am going to create this profile. That is, I am interested in creating this profile here. Okay, so this particular profile, okay, will be created. Okay, so it is like a rectangle, but on the top edge of the rectangle should be tapered. So that is what I am going to create in the front plane now. So I am going to select the front plane now. Okay, so first let me bring the model to isometric, and then I will select the front plane, then I will go to the sketch. Okay, so we need to create the sketch in the front plane. So what sketch will be created now? This one. Okay, this will be created. Now when I want to create this, I am going to see this particular keyway. Okay, this particular keyway here, its location is given with respect to this dashed line here, and you need to remember this because this top end of this keyway here is at a distance of 53.4 from this dashed line. So then the question is which is this dashed line? This dashed line actually corresponds to, okay, this inner circle of the flange. Okay, is that clear? So this dashed line corresponds to the inner circle of the flange here, that is it corresponds to the circle of diameter 50 mm. So therefore what I do now is since we need to give the location of the keyway with respect to the bottom side of the shaft wall, so I am going to turn on the hidden edges. So once I turn on the hidden edges, so I will be able to see the, okay, inner surface of the shaft wall, that is this one here. Okay, so from here I need to define the location of the keyway. So therefore the hidden edges have been turned on now. Then what I do is I will go for constructing this profile. So I will select the line command. Okay, so by selecting line command now, I am going to create a profile here. So this profile will be created something like this now. So draw a horizontal line. Okay, so and the keyway should be there from this particular face. So therefore I am going to draw this horizontal line up to somewhere here, and then I will draw one vertical line, then I will draw one tapered line up to somewhere here, then vertical line. So this profile has been created. Let me check. Okay, has been created. So keep it in front view. So then what I do is it's the time for adding dimensions. So dimensions needs to be added. So in order to add the dimension, they have given here this particular point, that is the top end, that is this particular point is at a distance of it is at a distance of 53.4 from this portion of the circle, that is from this point to this point they have given the distance. So that distance is how much? 53.4 mm. So therefore what I do now is I will select smart dimension, I will select this particular hidden line and this particular point, then you can go for giving this as 53.4. okay, and then what we need to do is we should go for giving the taperness here. So what is the overall length? Overall length is actually 80 plus 5, that is 85, means the distance from here to here is 85, means if we move from right to the left for a length of 100 mm, the reduction in height should be 1 mm, but here we are moving only by 85 mm, which is less than 100, so therefore the height should be decreased by 85 by 100, that is 0.85 mm. So therefore how to define that height now? Select smart dimension, select this right end of this tapered line here, okay, and this particular point. Okay, so smart dimension, select this point and this point. So try to give the vertical distance between this point and this point here. So this should be how much now? It should be 85 by 100. So this will tell us about reduction in height of the keyway from as we move from right face of the flange to the left face of the flange. Okay, and now as you can see here, this bottom line of this keyway is not constrained. So in order to constrain this, what you need to do is just remember like this. Okay, so you need to give suitable height here. So you have to give the height in such a way that, let me bring the model to solid form. So you have to give the height. You have to give the height of this line in such a way that this particular line should come out of should be below this inner circle. Okay, so that is what you should remember. That's why right now it is below the inner circle. Okay, so what I do, I will go for keeping in front view. I am going to define this particular height as approximately. Okay, so approximately I am going to take this as 8 mm. So just make sure that when you are defining this height, okay, so this line is coming below the inner circle. That's it. Just maintain that. Once it is done, okay, so what I am going to do now is I am going to cut the material. Okay, so you can see the sketch is fully defined now. Okay, and if you try to keep it in front view, it is going to look like this. Okay, it is going to look like this. Then come out of the sketch mode and then try to keep this in isometric view. Okay, so this is the isometric view now. So then what we have to do is we should go for cutting the material. So go to the features tab, go for extruded cut. Okay, so try to cut the material on either side of the created sketch. Okay, and it is going to appear like this. So in the right view you can see like this. So on either side we are cutting the material. Okay, and it should be for how much width now? What should be the width of the keyway? So width of the keyway can be seen. So you can see here, this is the keyway, and this corresponds to keyway here in the side view, and here they have given the width is how much? 16. So therefore when you are going to keep it in right view here, okay, so this particular width should be how much now? 16 mm. Give this. Okay, is that clear? Then click on OK. So this so you can see now. So this okay, so by using this extrude cut option, we have made keyway in the which one? In the flange. Okay, so try to keep it in front view, and if you want you can turn on the hidden edges. You can see we have made keyway here, and this particular line is tapered. Okay, so this is how we can go for modeling the keyway in the flange. Then what we need to do, so after making this keyway now, okay, it's the time for making these 4 holes, okay, which are 90° apart. Okay, and these 4 holes, the center of these 4 holes are lying on this pitch circle, and this particular pitch circle, you can see here, this particular pitch circle on which the center of 4 holes are located is having a diameter of 150 mm, means pitch circle diameter is 150 mm. You can see here. Okay, and each hole is having diameter of 16 mm. That is also mentioned here. And equi-spaced means they are 90° apart. So therefore, with this information, I will go for making the holes, 4 holes. So in order to make the holes, okay, so holes should be made here. Okay, so means on this particular face, hole should be made. This particular face means, okay, so here this corresponds to this selected area. So on this particular face, 4 holes should be placed. So how to place those 4 holes now? Select this particular face first, then go for sketch tab, then select sketch, then keep it in right view. So once you keep it in right view, first I am going to draw one circle now. Okay, this circle will be constructed for a diameter. Okay, this circle should have diameter of now. Okay, so this is a pitch circle now. Okay, pitch circle is having, it is given here. This particular pitch circle is having diameter of 150 here. So therefore I'm going to give this value as 150. Once you give the diameter of the circle as 150 mm, then what you need to do is you have to select the circle and make this circle for construction purpose only. Okay, this is not the visible edge. It is just for construction purpose. On this circle of 150 mm diameter, we have to place 4 holes now. So how to place the holes, that I will explain now. Select the circle command now. Exactly here on the top of this circle here. So go for drawing another circle. Okay, the center is the clear on exactly on the top of the circle of 150 mm diameter. Construct one more circle and give the diameter for this small circle. So this diameter now, okay, is how much now? Here it is given, it is 16 mm. So go for giving this as 16 mm now. Then what you have to do is like this you can also go for creating how many? 3 more circles, but I will not do that because you should now learn about one more new modeling feature called as pattern. Under that pattern you should learn about the circular pattern. That's why what we do is, okay, so we are going to first make one hole and then we are going to use pattern option and we will create the remaining 3 holes. So how it can be done? Let's see that. Okay, so now what I do, now the sketch is fully defined here. So I will come out of the sketch plane now. I will select the which one? Sketch 3, and I will go for features and then I will go for extruded cut. When I go for extruded cut, okay, so I will go for through all. Okay, so therefore the material will be cut here. Okay, so within that circle the material will be removed, then click on OK. So therefore one hole has been made. But now the question is how to make the remaining holes. Okay, in order to make the remaining holes, I will go to the features tab here. Then there is an option called as somewhere here linear patterns. So under the linear patterns, okay, so use the drop down menu here. Okay, drop down arrow, click on that, go to the circular patterns. Okay, then by using the circular pattern, first we have to specify which is the pattern axis. So this pattern axis should be selected as one of the circular edge. So either this circular edge or this circular edge or this circular edge should be selected. I am going to select this as the circular edge. Okay, now okay, so I need 4 numbers and the angle between two patterns should be what? 4. Okay, so I am spacing is 90 degree and 4 instances. Then what I do is here I need to select features to pattern. What I have to pattern now? I have to pattern this. See, I have to pattern this hole has to be patterned 4 times along okay, along this circle. Okay, so what I do now is I need to select the features to pattern. So just expand this part to here. Go for selecting cut extrude 2, because cut extrude 2 is nothing but this hole. So select the cut extrude 2. Okay, so then you can see now actually it is showing 4 holes. You can see the preview now. The 4 holes are appearing, okay, within 90 degree. Okay, and there are 4 in number within 90 degree. So what we need to do now is we need to change this 90 degree as how much now? 360. Okay, then what will happen? Okay, for 360 degree rotation, okay, 4 holes will be placed and they are equally spaced. You can see it here. Then click on OK. So what you have to remember here is first you have to select the edge or the pattern axis. Okay, any of the circular edge can be selected and then you have to give the angle as 360 degree. Then how many counts you require? Suppose instead of 4, if you want 6, okay, and then it will come like this. If you want 8, it will come like this. Automatically it will adjust the angle, okay, between the 2 adjacent holes. So therefore what I do for this particular problem, okay, 4 are sufficient. That's why by using pattern option, we can go for saving our time when we want to make the same kind of holes several times. Okay, so patterns will be more useful in this kind of situations. Then click on what? Okay. Is that clear? So this is how we have got 4 holes on a circle of diameter 150 mm. So that has been done. Now let's check is there any other thing that we need to add here. I think is there any other thing? Okay, so flange has been made, then the keyway has been cut, this chamfer has been added, okay, and circles holes have been made for inserting the bolts. Okay, and if you look at here, it looks like there is a fillet. So there is a fillet here, there is a fillet here, Okay, so if you look at this part drawing sheet, all fillet and round should be of radius 3 mm. It is given here. Unless otherwise mentioned, you have to stick on to this. So therefore, if you want to add fillet here and if you want to add fillet here, okay, so that can be added now. Okay, so where it can be added? So just I will try to keep it in isometric view, and I will slightly turn this. Okay, now I will go for using fillet option. I will select this particular circular edge, and I'm going to give this as 3 mm radius, and which is another one. So here it looks like fillet, and here also it looks like there is a fillet. Okay, so I'm going to select this one now. These two circular edges will be selected, and fillet radius of 3 mm has been assigned. Then click on OK. Now if you try to keep it in front view, it is going to look like this. Okay, and I'm going to turn on even the hidden edges now, so that we can verify this front view with front view given here. Okay, so you can check it now. I think this particular front view which we have got now is exactly matching with the front view of this part drawing sheet. Okay, so therefore flange number 1 is complete now. So therefore let me go for bringing this and also if you want you can keep it in left view now. So this is how it looks. Okay, so this is the left view, you can see here. Okay, so it's looking perfect now. Okay, so it is looking perfect. So I'm going to bring back this to the isometric view, and I'm going to bring it to solid form. Okay, and then I'm going to fit this to the window, and then I'm going to save this file now. So I'm going to save this file on the desktop. On the desktop I'm going to create a folder by name flanged coupling. Okay, and then inside that folder now I am going to save this as part number 1, that is flange number 1, and this file will be saved as a .prt file. Okay, so this completes the modeling part of the which one, flange number 1. Okay, now it's the time for taking up the modeling of flange number 2. Now you may be thinking that whether we need to again do the same thing what we did for flange number 1 for flange number 2. Okay, whether we need to do the same thing for flange number 2. So what I will suggest now is, once this particular flange number 1 is saved, okay, so what I will do is I'm going to again go to the file here. Okay, I'm going to save this file again as save as. Okay, so I'm going to save this same file as part 2. Okay, and I'm going to rename this as flange number 2. Already one file is saved as flange number 1. Same file will be saved one more time now, and it will be saved as flange number 2. Why I am doing this is, okay, if you look at this flange number 1 here and flange number 2, okay, so if you try to compare the okay, for flange number 2 now they have given the front view, and they have given the which view here, they have given the right side view. And if you try to check the left side view of the flange number 1 with the right side view of the flange number 2, you can see both are almost one and the same. Okay, so both flange number 1 and flange number 2 are appearing almost same in their side views. Okay, but only difference is there in their front view. That too, okay, let me show it here. Okay, so in flange number 1, actually, okay, we have small projected cylinder here. Okay, for a length of 5 mm. For a length of 5 mm, there is a small cylinder here for a diameter of 75 mm. But okay, in the case of flange number 2, okay, for a diameter of 75 mm, we don't have a cylinder. Instead of that, there is a hollow cylinder here. So, and that is having diameter of 75 mm. And what is the depth of this hollow portion here? It is 6 mm. That is the only difference. Other than that, this flange number 1 and flange number 2 both are one and the same. You can compare here. This side diameter is 100, diameter is 100, length is 80 here, length is 80 here. Okay, so here it is 46, here also it is 46. Okay, and then Then other than that, okay, so here it is 216, 216, 150 piece circle here, 150 piece circle here. But only difference now is, in the case of flange number 1, there is a small cylinder here for a diameter of 75 mm and length of 5 mm. While in the case of flange number 2, okay, so in this portion we don't have a cylinder. Okay, we don't have solid portion. Instead of that, there is a hollow portion, and that hollow portion is having diameter of 75 mm and depth of 6 mm. So therefore, what I am going to do now is, already this file has saved as part 2, that is flange number 2. Okay, so what I do now is, simply first I will remove this. What I do is, in order to convert this flange number 1 as flange number 2, okay, simple step is, first remove this extra cylinder which is present here for a length of 5 mm. So first cut and remove that, and then go for giving additional hollow depth of how much here? 6 mm. That's it, for a diameter of 75. So what I do, first I will remove this projected small cylinder here, which is having the outer diameter of 75 mm. How it can be done? I will select this particular face now. Okay, I will go for sketching on that face, and I will keep it in right view now, and I am going to construct one circle there. So circle will be constructed. Okay, so you can select like this, or first you can draw one circle and you can give this value as 75 if you want. Okay, so then once that circle is constructed on this particular face here, then you can come out of the sketch plane, because sketch is fully defined. Then go for features, and then go for extruded cut, and change the, so right now the material is cutting towards the left side. Change the direction of cut now, reverse the direction, and go for through all, and then click on OK. So now we have removed that extra 5 mm projected cylinder, okay, from this particular face. Once it is done, now what we have to do here, again we have to cut the material for 6 mm depth for a diameter of how much here? So for a diameter of 75 mm. So that is what I will do now. I will select this particular face, and I will go for sketch. Okay, and I will keep it in right view, and I am going to select the circle command. I am going to draw one circle here. Okay, so this should be constructed for a diameter of how much now? 75 mm. Okay, so once it is constructed for 75 mm, okay, so it is already fully defined now. Come out of the sketch plane. Okay, then you go for features, then go for extruded cut now. Okay, now what should be the depth of cut? Depth of cut should be equal to 6 mm. Okay, this is the only difference. Here the depth of cut is 6, here the projected length is 5. Okay, so first we have to remove this 5, and then we should go for again inner side of the flange, okay, by 6 mm. Okay, so that is what I am trying to do now. So this depth of cut should be 6 mm now. Okay, so this is how it looks now. So now this is actually the flange number 2. There is no need to do anything else for this flange number 2. So whatever we have got now, this is the okay, isometric view of the flange number 2. I am going to save this file now. Okay, so already the file has been saved as flange number 2. So this is what you need to remember when you are working on modeling and assembling of the flanged coupling. First create the flange number 1, then copy the flange number 1 as another file. Then that in that another file, okay, you just go for removing this 5 mm projected length first, and then go for giving 6 mm depth of cut for a diameter of 75 mm. That will make the flange number 1 as flange number 2. Okay, but before you doing this, make sure that you are saving the file as another file. Okay, don't simply modify the file number single file itself. Okay, so you should use the option of file save as. Otherwise, you just close this file, copy the file that you have saved as another file, part number 2, then you work on it. Okay, so how we are going to do that, it is left to you, but it is a simple way of converting flange number 1 into flange number 2. Once it is done, okay, so we should go for creating the next part, that is shaft number 3. So which is the shaft number 3 here? So shaft number 3 is shaft. Okay, so this shaft is given here. For the shaft, okay, they have given two views. That is, this is the front view, okay, and this is the side view. So therefore, let me go for showing how this part 3 can be created. I will go to the new, I will go for part. Okay, so now I will select. So first I will try to create the left view. So they have given the left side view here. Okay, this is its front view. So first I will create one circle in the which plane? In the right plane. Okay, so what I do now is I am going to select the right plane. I will go for clicking on sketch there, and I will select the circle command. I will draw one circle here, and this circle should have diameter equal to shaft diameter. What is the shaft diameter given here? So you can see here this shaft diameter is given as 50 mm. So therefore I am going to give this diameter as 50. Okay, once it is done, click OK, and the sketch is fully defined now. Exit from this. So keep it in isometric view so that you can see where exactly you have created this one. So this is your front plane, this is your top plane, this is your right plane. So circle has been created on the right plane. Then select the sketch one, then go to the features. Okay, so by selecting the feature, by selecting the extruded feature now, so I can go for adding the material. So I am going to add the material towards the left side now. Okay, means I am going to reverse the direction here. Okay, and it should be added for a length of how much? 90 mm plus some extra portion here, but they are not given what is the length of this extra portion of the shaft here. So I am going to take this as around 30 mm. So therefore by taking it as 30 mm, so total length of this shaft will become 90 plus 30. I assumed it as 30. Okay, done, because this portion of the shaft length is not given. Is that clear? So once it is done, so the shaft is ready, but in this shaft we have to make a keyway. Okay, so keyway was made in the flange up. In the same way we have to make the keyway in the shaft also. Okay, so therefore we need to make this keyway which is having a width of 16 mm, and when it's seen in the front view, okay, so the bottom face of the keyway is flat. Okay, while the top there will be no question of top edge here, so just we need to maintain one flat face. The bottom face of the keyway should be flat, and it should have a length of how much? 90. So therefore what I do now is I go for, so this is going to be my front view. Okay, so since this is going to be my front view, so what I do is I will go for selecting the front plane. I will go for creating the sketch on the front plane here, and then I will select on rectangle command. So then what I do is starting from somewhere here, I am going to construct one rectangle like this. So rectangle will be constructed, and by constructing that rectangle now I am going to give the length of this rectangle as 90 mm, and the height, and the bottom face of this keyway. So you need to remember here the bottom face of this keyway here, okay, is at a distance of 44 mm from the base of the shaft. That is, from this base of the shaft here, okay, the base of the keyway is defined, that is 44 mm. So what we need to do is, so I am going to give the distance from, so, and you need to remember this base of the keyway, okay, is nothing but this particular hidden edge. Okay, so therefore the distance from this particular line to this base of the shaft should be how much now? It should be given as 44 mm. So therefore I am going to give this as 44 now. And then the question is what should be the height of this rectangle. So height of the rectangle can be suitably taken, but only condition here is this particular top line should be outside the upper surface of the shaft. Okay, so I am going to take this as around 8 mm. That's it. So it should be above the shaft. Okay, so once it is done, so now it is created like this. So sketch is fully defined. Exit from the sketch mode. Okay, so then what you have to do is go to the features, go to the extruded cut. Okay, so now what should be the width of the cut? The keyway should have width of 16 mm. So therefore I am going to give this as 16 here. Okay, and it should be cut on both the side of the profile. So therefore it should be like this. So we are trying to cut the material something like this. Okay, from the mid plane or from the front plane. So it will come like this. Then give it OK. So the keyway has been made. Okay, so this is the flat face. This particular face is at a distance of 44 mm from the base of the shaft. Okay, so then what we need to add? So let's check. So the left face of the shaft should be chamfered with a 2 mm length and 45 degree. So I'm going to use the chamfer command now. I will select this particular circular edge and I'm going to give the chamfer length as 2 mm and 45 degree. Then give it OK. So chamfer has been made. And here it looks like there is a fillet. Okay, so it looks like there is a fillet. Again, unless otherwise mentioned, all the round should be of 3 mm radius. So therefore what I do is I am going to select the fillet command. I will select this particular edge here, and 3 mm radius will be given to that, like this. Now if I try to keep this in front view, and if I turn on the hidden edges, okay, so this is how it looks. So this front view is almost matching with the front view of the shaft given here. Okay, so it is almost matching with the front view of this. So therefore the modeled shaft is correct. Shaft is correct. So let me bring back this shaft to the solid form. Then I am going to save this as part 3, and name will be given as shaft. So this completes the modeling of part number 3, that is shaft of the which one? Shaft of the flanged coupling. So now next one is we need to create the shaft. Part number 4 is the taper key. So let me quickly finish even the modeling of taper key. So taper key is given here. So this is the part 4. That is the taper key. So how it can be done? So again we go for creating this profile. So this is the front view of the taper key, and this is the right view. Okay, so this is the right view, right side view of the taper key. This is the front view. So what I do now, let me close this graphics window. Then I will go for new part again. So okay, then select the front plane, go for sketch. Okay, so then select line command. Okay, so then try to create this profile in the front view. Okay, or in the front plane. So therefore what I do, I will draw one horizontal line, then one vertical line, then again inclined line, then again horizontal line. So now what should be the length of this key? So length of the key should be 85 mm. Go to the smart dimension, define the length of the key as 85 mm, and then the height. So the height is given here as so in the right side view you can see the distance from this top edge to the bottom edge of the key is 10 mm. So this top edge corresponds to this particular point in the front view. So therefore the distance from this point to this point is 10 mm. Means the height of the key on the right side is 10 mm. Okay, so then the question is what should be the height of the key on the left side? So but they have not given the height of the key on the left side. Instead of that they have given, okay, what is the taper of this key? So taper of the key is 100 mm. Okay, sorry, 1:100. That is for every 100 mm length of the key, 1 mm height should decrease. Okay, so if it is 10 mm on the which side? Right side. Then okay, so if the key length was 100 mm, then 1 mm was to be decreased. Okay, that is on the left side the key height should be 9 mm. Okay, when overall length of the key is 100 mm, but now right now okay, the overall length of the key is only 85. So therefore the height should decrease by how much? 85 by 100. So how to define that? So that can be defined something like this. So this is the entity which is in blue color, means its height can be varied like this. So now I will select smart dimension. I will select the right end of the tapered line and the left end of the tapered line, and I will define the horizontal distance between them. So this horizontal distance is nothing but how much height is decreasing. So this should be how much now? It should be 85 by 100, means height should decrease by 0.85 mm. Okay, once this is done, okay, so you can see the sketch is fully defined. Okay, sketch is fully defined. You can keep it in isometric view, come out of the sketch mode, and now what you can do, you can go to the features, you can go to the extruded boss, means we can go for adding the material, then go for mid plane option. Here what should be the width now? So in the right side we can see the width of this key as 16. The width of the key is 16 mm. So therefore we are going to give the width or the depth of extrusion as 16 mm. Okay, so now if you try to keep it in front view, this is how it looks. Let me change it to the solid wireframe mode. Okay, with the hidden edges. So this is how it looks. So this exactly matches with this front view here. And if I try to if I try to see the right view of this keyway, so it is going to look like this. So this is exactly same as this. Okay, so right view is is looking like a rectangle with there is a hidden edge here. So that hidden edge is also shown here. Okay, so therefore this completes the modeling of part number 4 of the which one? Flanged coupling, that is tapered key. So just go for saving this as part number 4 and then taper key. Give the name as taper key. Next, we are going to look at how the part number 5 and 6 can be modeled, which are external bolt and external nut, which are given somewhere here. Okay, for external bolt they have given the front view. For external nut also they have given the front view. So based on these front views of the bolt and nut, we have to model these two. Then once these 5th and 6th part are completed, okay, we will be ready for assembling all the parts. Okay,